Welcome to today's Explainer. So, today we're going to examine the totally invisible architecture of our digital world, specifically the blueprints used for database design. I mean, we all know the apps we use every single day rely on these massive underlying data structures, right? But the actual process of mapping out that structure before writing even a single line of code, well, that's kind of an art form all in its own. Let's unpack the visual frameworks that actually make this whole thing possible.
Think about it like this. Imagine trying to build a massive 100-story skyscraper without a blueprint. You wouldn't just show up to an empty dirt lot with a huge pile of steel beams, some glass, and a hard hat and just start guessing where things go. Obviously, that would be an absolute disaster. Well, the exact same logic applies to databases. When a company needs to organize, say, 1 million pieces of data, stuff like customer names, order histories, shipping routes, they absolutely need a master plan to ensure it doesn't just evolve into total chaos.
Okay, let's dive into this. Here's our roadmap for today. We're going to start with the database blueprint, move right into data modeling, and then break down entities and attributes. After that, we'll get a handle on cardinality constraints before bringing it all together with a real-world UPS tracking challenge.
Step 1. The database blueprint.
Now, this diagram you're looking at acts as that essential blueprint. Notice how it maps out the tables and their relationships. Basically, this is the very first stage of design. It's the process of capturing all those critical concepts and the specific rules that shape a business, and mapping them out conceptually way before any physical implementation actually happens. This visual architecture literally becomes the schematic that engineers use to build the physical database later on.
Moving on to Step 2, Intro to Data Modeling. So data modeling serves as the ultimate organizational tool. It's a highly detailed, logical representation of an organization's data. And what makes this phase absolutely crucial is its pure focus on business needs. At this point, we are just mapping out the ideal conceptual state and the vital operational rules, and we're totally unconstrained by what is physically possible to program later. We're just focusing on what the business actually needs to do.
So the crucial point is that this phase really has 3 main goals. First, describing what data is actually contained in the system, like students and lecturers. Second, mapping the relationships between those items, like lectures teach courses. And third, and honestly this is probably the most important part, defining the constraints or the rules. For example, setting a rule that a student number literally cannot be blank or null. That establishes absolute data integrity right from day one.
Okay, 1976. This was a hugely pivotal year for computer science. Before this, organizations basically relied on older database models, like the flat file model, the hierarchical model, or the network model. But in 1976, Peter Chen introduced the Entity Relationship Model, or ERM, and this was a real game changer. It completely revolutionized how we visualize data because it explicitly included all the entities and the relationships among them, illustrating the whole thing through what we now call an ERD, or Entity Relationship Diagram.
All right, Step 3, Entities and Attributes.
Let's break this down. An entity is basically the actual object we want to track. It could be a person, a place, or an event. The attributes are its specific properties. Now, we divide these attributes into 2 types. On the left, we have single or atomic attributes. These literally cannot be divided any further. Think of something like an age of 23 or a person's first name. But on the right, we have composite attributes. These can actually be broken down into smaller subparts, with each piece holding its own independent meaning within the database architecture. And this brilliantly illustrates exactly what we're talking about. We're looking at a mapped-out employee entity. You can clearly see single attributes like name, salary, and birth date. But look at address. It's a composite attribute splitting perfectly into way number, street, and city. Each of those subparts has its own independent utility, but when you put them together, they form the broader concept of an address. It's actually incredibly elegant when you see it mapped out at this granular level.
Step 4. Understanding cardinality constraints.
So, what does this all mean? Well, cardinality essentially dictates the physics of our digital building. It defines the mathematical minimums and maximums of how different entities interact with each other. Formally, it's the number of instances of entity B that can be associated with each instance of entity A. To put that into perspective, imagine a media database. A single extended edition movie entity might link to, say, 3 or 4 physical CDs. That maximum limit right there, that's our cardinality.
Along with those maximums, we also have to define participation minimums. On the left side here, if the minimum cardinality is 0, the relationship is optional. Basically, it doesn't absolutely have to exist. But on the right side, if that minimum is a 1, Participation is mandatory. That structural link becomes an absolute requirement that is locked in. If the database is going to function correctly, that link has to be there.
And finally, step 5, the UPS tracking challenge. Let's see this in action.
Okay, here is the core business scenario. UPS prides itself on having totally up-to-date information on the processing and current location of every single shipped item. I mean, to pull this off, they rely on a massive company-wide information system. As our source material highlights, shipped items are the heart of the UPS product tracking information system. So, as data architects, the challenge is, how do we take a standard paragraph describing a huge, complex real-world business need and actually turn it into a structured, elegant data solution?
Now, what's really interesting about this slide is how we actually do that extraction. We take actionable data points from that dense business requirement and use them to structure our blueprint. First, we isolate our primary entity, which is shipped items. From there, we start pulling the attributes. We grab item number to serve as a unique identifier. We pull weight and dimensions as our atomic attributes. Insurance and destination become key data points. And finally, final delivery date gives us our timeline data. Just like that, we've translated a totally chaotic, real-world operation into a highly structured, logical model that is completely ready to be diagrammed.
And that brings us to the end of our foundational journey into data modeling. We've seen exactly how blueprints prevent total chaos, how entities and attributes form our basic building blocks, and how rules like cardinality keep everything perfectly mathematically aligned. So, I want to leave you with a final thought to ponder today. Next time you open your phone, take a step back and look at your favorite streaming service or social media app. If you were the data architect tasked with mapping it out, what would its entity relationship diagram look like? What are the mandatory rules? What are the composite attributes that are holding your specific profile together? If you look closely enough, you'll actually start seeing these invisible blueprints everywhere. Thanks for hanging out with me on this explainer, and keep exploring the architecture of our digital world.